Let us discuss about the structure of diborane. Borane, atomic number 5, 1s2, 2s2, 2p1. In ground state, the orbitals are filled like this. There are 2 electrons, here 2 electrons, and in p orbital 1 electron. Then excited state, here the 1s orbital there are 2 electrons, but in the outermost shell, here 2s electrons are excited to, one of the 2s electron is excited to the 2p orbital. Therefore, here 3 single electrons are there. In diborane, 1s 3p orbitals are used up, and borane is sp3 hybridized. 1 s orbital, 2 p orbitals, and these 3 are half filled, and 1 p orbital is empty. Now take hydrogen. The electronic configuration is 1s1, therefore this contains only 1 electron in this s orbital. Then we can say orbital of hydrogen is half filled. This is the structure of diborane, that is one boron linked with 4 hydrogens, bonded with 4 hydrogens. Another boron that is also bonded with 4 hydrogen atoms, but these 2 boron atoms are linked by 2 bridged hydrogens. Therefore, we can say this is one BH2 unit and this is another BH2 unit. Therefore, these 2 BH2 units are linked by 2 bridged hydrogens. Then we can say, here we can see 1, 2, 3, 4, 5, 6, 7, 8. Therefore, there are 8 BH bonds. 1 BH, BH, like that. 8 BH bonds are there. Bonds are there. Here diborane has only 12 valence electrons. Here you see 2 boron, therefore 2 boron, 3 single electrons. Okay, here there are 3, here you see there are 3 single electrons, therefore 2 into 3, 6 electrons. 6 hydrogen, only 1 electron here, therefore here we can say 6 hydrogen atoms, 6 into 1, 6 electrons. Here 4 terminal BH bonds, here BH 1, 2, then 3, 4. Therefore, there are 4 terminal BH bonds and are normal covalent bonds. That is here BH, this is a covalent bond. Covalent bond, this is also a covalent bond, this is also a covalent bond. Now you see 2 center 2 electron bond. Therefore, these are called as 2 center. That is 1, 2, 1, 2, 2 center. 2 electrons. It donates 1 electron. It also donates 1 electron. That is 1 plus 1, 2 electrons. Therefore, we can say 2 center, 2 electron bond. Therefore, for these 4 terminal BH bonds, 1, 2, 3, 4, for these 4 BH bonds, 8 electrons are used. We have only 12 valence electrons. Remaining are 4 bonds. That is BHB, BHB. Therefore, BH, 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 BH. 4 bonds are there. We need 8 electrons. We have only 4 electrons. Therefore, the bridged bonds BHB utilizing 2 electrons each. We have only 4 electrons. Therefore, for this 2 electrons and for this 2 electrons, they are used. Therefore, 1 boron, 2 hydrogen, 1 boron. Therefore, 3 center. And this used up only 2 electrons. Therefore, we can say 3 center, 2 electron. In boron, diborane, boron is sp3 hybridized. Already we know that 3 of the 4 sp3 hybrid orbitals, 3 of the 4 sp3 hybridized orbitals are half filled. That is, if you see here, this is half filled, 1 electron. Here also 1 electron. Here also 1 electron. And this is empty. Like this, here also, this contains 1 electron, this contains 1 electron, and this orbital contains 1 electron. This is empty. Therefore, during the formation of this bond, one of the electron from this orbital of this boron is overlapping with this hydrogen and the empty orbital of this boron. This bond is formed by the overlapping of the orbital contains one electron of one boron and the empty electron of other boron. Therefore, for a bond formation, we need two electrons. Therefore, the two electrons are obtained from hydrogen, one electron, and boron, one electron, and the other orbital is empty. Here, this orbital is empty, and this the orbital from this boron gives one electron, and one is from hydrogen. Therefore, these two BHB bonds are formed. Here you can see BHB bond overlapping of half-filled orbital of boron, half-filled orbital of hydrogen, and one empty orbital of boron. Like this, the structure of diborane can be explained.